Hello everyone, this is the first update on the build of Kaneda.
Kaneda!
My new antweight spinner. So this is a bit of an evolution from my previous design, Gremlin, which some of you guys may be familiar with. Yeah, I'm sure lots of you thought Little Gremlin. Gremlin did a good job actually. It was a great way to learn about a lot of the fundamental skills involved in making a combat robot, but I think it's time to move on and do something a bit more advanced now. So yeah, amongst other things, Gremlin was a bit slow and had this really rather annoying trait of being rather thin and postable down the edge of an antweight arena, which happened, yeah, too often. Oh wow.
That's out.
I think I'm immobile. So, moving on to a new design now, hoping to make this thing a little more compact, a bit more robust, and also to add an active weapon, and also make some enhancements to the armour actually. So, even though Gremlin itself is quite tanky, I don't think Gremlin ever really got a full-on whack. It never got, sent flying across the arena by a vertical spinner or anything like that, and I'm not sure how well it would stand up to the punishment really, just being pure 3D printed PLA, so yeah. So this is the new design. So I've done this one in Fusion 360, which has been an experience. So Fusion 360, for those unaware, that's a parametric CAD system. So what that basically means is you have to set up every little feature of this model in terms of, well, parameters. These parameters are, lots of little formulae and dimensions and stuff like that, and they, what it means is if you want to make a change halfway through making a model like this, you just go back and edit the parameters and everything sort of changes in size, and the whole thing kind of hangs together on all the numbers that you've put in. And there is a learning curve of that, but I think it's a worthwhile one actually. For anyone who's interested in doing this sort of thing, like making combat robots, I think 3D printing is a nice way to go, especially because you can mail order 3D printed parts pretty cheaply these days. And if you're going to do that, getting to grips with a decent bit of CAD software, yeah, I'd say that's quite an important step. So it took a few weeks to do Kaneda. I can't remember the number of hours to be honest, but put it this way, it certainly wasn't full time. This was just evenings and weekends tinkering around with it, and now I feel like I could probably do something of a similar level of complexity pretty quickly actually. A lot of the effort at first is just learning where things are, but fairly happy with that one now. So here's an earlier attempt at printing this. So yeah, one of the frustrating bits about this development so far is the fact that I've had to redevelop a lot of the 3D printing parameters from scratch. So my old hard drive died and took with it a lot of the parameters that I'd spent ages honing for the printer itself. So all this bump you see in the background here, this is a bit of a graveyard of trial and error on the 3D printer to try and get the parameters right. So as you can see, we get lots of these pretty little fractal trees that come out when you haven't got the temperature or the extrusion rate right on the printer, but many attempts later we're getting towards something that just about works. So moving on from this, which had, among other things, in fact it was a bit too heavy and had some other assembly flaws as well that stopped me putting the weapon in, which was a bit of a pain. So moving on from that, we have new housing. So that's currently underway on the printer. Everything is looking a lot nicer now. It's not covered in horrible stringy bits, and hopefully it will actually fit and be the correct weight. So fingers crossed for that one. So the weapon. So you may have seen I've got another video on my channel showing a test spin of the weapon. So electronically that's working pretty nicely actually, and I think mechanically as well it looks pretty smooth. So this was designed to have a slightly offset axis of rotation to account for the fact we've got a round thing with a little tooth on that puts the centre of mass off balance. So I've balanced out the centre of gravity of this, and it looks pretty good actually. It spins pretty neatly, up to a theoretical max of about 29,000 RPM. As to whether we see that in practice, to be seen. But yeah, in theory, you should hit with about 10 joules of kinetic energy. So yeah, we'll see how it goes. I mean, this is new to me, so yeah, it's a fun experiment, but we'll see what happens in the arena. So this is a direct drive spinner, and this is powered by this little brushless motor here, 4000 kV brushless motor. Yeah, one of the major issues with this motor is the screws that come with it don't really seem to fit very well. So if I can get this into the light, we have these 4 little holes there on the end. That's where you would normally screw down a propeller. Now the screws that come with it actually foul the prop shaft and kind of stick out a bit, and that was okay for a quick spin-up test on the little rig I've got over here that it was running on, but I don't think that's any good in the arena, so I had to trim down these screws a little. So I made a little poor man's lathe setup and put these screws into threaded inserts, pop them into a drill, and then span the drill while I filed down the edges. So they fit a lot neater now. So yeah, so far so good on that. Another issue with direct drive is, of course, you've got the actual weapon is hanging on the end of the shaft there, and we don't want this thing to just bend around like that. So what I've also created is this little bearing housing here. So this is a little snap fit 3D printed bearing housing that I'm going to make a bit more robust with some epoxy soon. But that will support the weapon from the other end. So looking at it on the CAD scheme here, so you see it here just in front of the battery. Yeah, that should hopefully make us a bit more immune to the shaft bending or anything like that. But again, this is all a bit of an experiment. The actual drive of the thing, so it's N20 gear motors with a 30:1 gear ratio, so identical to Gremlin basically. Not the fastest, but then I'm not the most experienced of drivers. I might upgrade this in the future, because Gremlin was slow, no doubt about that. I think it did limit it a bit in combat, but then at the same time, I never accidentally drove Gremlin into the pit. So I'm not sure which is the lesser of two evils here, but we'll have a look at that one. Speed controller is the DAS Micro 6 amp speed controller, way lighter than this big chunky saber tooth that I've got in Gremlin. So that does save quite a lot of weight actually, which makes room for more big splashy weapons. So hope you guys like the theme for any Akira fans out there. So I might have to print out some decals and try and keep the theme in keeping with Kaneda's bike. Because that's pretty good. Radio wise, I'll get this little wire out of the way. This is just the same as we used in Gremlin, so Orange RXR 410X. In fact, this may have just been stolen from Gremlin, but I'll replace that. The armour panels. So the 3D print itself, not sure if you can see, it has, let's move this into the light, these little slots in the side. And okay, this is obviously a bad print, but this will be a little nicer the next time around. These are little sort of slot panels that I'm going to put carbon fibre epoxy into. So I'll be doing an update on this soon about how I intend to cut out these diddy little bits of carbon fibre and get them into the design. I think I've got a way forwards for that. It worked quite nicely, so I'll update on that. But hopefully that should be an awful lot stronger than just printed PLA. So that should take a few whacks on the side before that starts to break. That's about it for now. I will keep you guys updated as the build goes on over the next week or so. And thanks for watching.